The Dynamic Host Configuration Protocol version 6 is a network protocol for configuring Internet Protocol version 6 hosts with IP addresses, IP prefixes and other configuration data required to operate in an IPv6 network. It is the IPv6 equivalent of the Dynamic Host Configuration Protocol for IPv4. IPv6 hosts may automatically generate IP addresses internally using stateless address autoconfiguration, or they may be assigned configuration data with DHCPv6. IPv6 hosts that use stateless autoconfiguration may require information other than an IP address or route. DHCPv6 can be used to acquire this information, even though it is not being used to configure IP addresses. DHCPv6 is not necessary for configuring hosts with the addresses of domain name system servers, because they can be configured using Neighbor Discovery Protocol, which is also the mechanism for stateless autoconfiguration. Many IPv6 routers, such as routers for residential networks, must be configured automatically with no operator intervention. Such routers require not only an IPv6 address for use in communicating with upstream routers, but also an IPv6 prefix for use in configuring devices on the downstream side of the router. DHCPv6 prefix delegation provides a mechanism for configuring such routers. Operation equals port numbers equals DHCPv6 uses UDP port number 546 for clients and port number 547 for servers. Equals DHCP unique identifier equals the DHCP unique identifier is used by a client to get an IP address from a DHCPv6 server. It has a minimum length of 12 bytes and a maximum length of 20 bytes. Its actual length depends on its type. The server compares the DUID with its database and delivers configuration data to the client. The first 16 bits of a DUID contain the DUID type, of which there are 3 types. The meaning of the remaining 96 bits depend on the DUID type. Example equals, in this example, the server's link local address is FA80.01122FF, FA335566 and the client's link local address is FA80.org, CCFF-FDIF. DHCPv6 client sends a solicit from FA80.org, CCFF-FDIF 546-4, FF0212, 547. DHCPv6 server replies with an advertise from FA80.01122FF, FA335566, 547-4, FA80.org, CCFF-FDIF 546. DHCPv6 client replies with a request from FA80.org, CCFF-FDIF 546-4, FF0212, 547. DHCPv6 server finishes with a reply from FA80.01122FF, FA335566, 547-4, FA80.org, CCFF-FDIF 546. IETF Standards, RFC 3315, Dynamic Host Configuration Protocol for IPv6 updated by RFC 6221, RFC 4361, RFC 3319, Dynamic Host Configuration Protocol Options for Session Initiation Protocol Servers, RFC 3633, IPv6 Prefix Options for Dynamic Host Configuration Protocol version 6, RFC 3646, DNS Configuration Options for Dynamic Host Configuration Protocol for IPv6, RFC 3736, Stateless Dynamic Host Configuration Protocol Service for IPv6, RFC 5007, DHCPv6 Lisa Query, RFC 6221, Lightweight DHCPv6. Relay Agent Updates RFC 3315, Errata. See also, Comparison of DHCP Server Software, Neighbor Discovery Protocol, which also supports DNS configuration. References. External links, IPv6 Intelligence, DHCPv6, Comparison of DHCPv6 Packages and Implementations, IPv6 Ready, DHCPv6, List of IPv6 Phase 2 certified DHCPv6 implementations.